Hi guys, and welcome again. Today we are doing grade 12 maths paper 1 and we are looking at question 4 from the November 2025 paper. We are given this log graph, log 1 over 3 to the x. It might be a little bit small, so for those of you on your cell phones, I'm just going to actually just write this as f of x equals log 1 over 3 x. And the first question asks, calculate the value of t. Okay, so we see the t as a point on this graph and we're given the value x. So all we do is we simply just write f of 3, because the x value is 3, is equal to log 1 over 3, 3. Okay, and we can put that into our calculator and we will get -1. There we go. So that is -1. Okay, so therefore t is equal to -1. All right, write down the coordinates of A. So the coordinates of A is the x-intercept. So that is where y is equal to 0. So we can say, I'm going to do 4.2 here. Let's do it in a different color just to be a bit fancy. So 0 equals, so this is 4.2 we're doing here. 0 equals log 1 over 3 x. Okay, and now what we can do is we can, so I'm just going to show you quickly the way I do remember logs is I remember log base number equals exponent. Log base number equals exponent. Because if you think about it, the base is the base of a tree. The exponent is the thing at the top of the tree because your exponent's at the top, and your number is your number by itself, right? So log base, so the base is a third. The number is x, and your exponent is 0. Well, anything to the power of 0 is 1. Okay, so x is equal to 1. So the coordinates of A are 1 and 0. Okay, another thing I just want to tell you guys is that the log graph is the inverse of an exponential graph. So if you remember, an exponential graph, I'm going to draw in red, would go like this. And it would always, if it's just a regular, like let's say, we'll call this g of x, is equal to, say, 2 to the x. Then where you make x 0, 2 to the power of 0 is 1, right? But even if you made this, even if it was 3 to the x, it would still be 1. So remember our exponential graph, the y-intercept is 0. So if the log graph is the inverse, then it makes sense that the x-intercept would be the same as the y-intercept. That is because an inverse graph is where you swap x and y. So, okay, so just the take-home message there is that the log graph is the inverse of an exponential graph. And wow, as I've said that, we suddenly get determine the equation of f of 1, the inverse of f. Okay, so, and when I said what is the inverse, that's when you swap x and y. Okay, so well, let's just clear that. And we were going to do 4.3 here, and we'll do 4.3 in red, but I'm not going to do, I'm going to do it on the document here. Okay, so we've got the document. So 4.3, we have a inverse. So what does that mean? Swap x and y. So I'm going to say x equals log 1 over 3 y. And now I simply get y by itself. So I remember that thing, log base number equals exponent. Log base number equals exponent. I've said that a few times because drill it into your head. Log base, so the base, the thing at the bottom, like the base of a tree or living in the basement. Not a place you want to be, but it's at the bottom. Log base number, the number is the thing by itself, right? And then your exponent log base number equals your exponent. The exponent is there, so that's x, right? All right, so we've done it, and then it needs to be in the form of y equals, so that is. So we can say y equals a third to the x. Okay. Write down the equation of the asymptote of your inverse. Okay, the asymptote of the inverse. Well, all we need here is the asymptote of f of x, and it'll just be swapped. Okay, so the asymptote of your log graph, can you see that it never crosses your thing? So I'm going to do this a couple of ways to show you. Okay, so the first thing is we see you have this asymptote of f of x, which is x equals 0. Let me just do that in black. Of x equals 0. Which means the asymptote of the inverse will be at y equals 0. Right? So the inverse here would be y equals 0. And remember, I even drew it there. And we saw that it was we know that it's an exponential. So I'm going into a little bit more detail than you need, maybe. Maybe you're just looking for the answers. But if you are here for a bit of extra knowledge, you're welcome. Okay, so what did we say? We said it's going to be the inverse would be y equals 0. Okay. I'm going to clear all the drawings, and I'm going to use this. And so we said that it was y equals 0. Okay, now draw the graph of f to the minus 1 on a separate set of axes, clearly indicating the intercepts of the x with the axis, the coordinates of one other point, and the asymptotes. All right, so I'm going to draw it here. So I might as well have just kept that there. But anyway, okay, so we know we've already figured out what A is. A is, I want to do this in blue. A is 1 and 0. Which means we know that we're going to have a point, an intercept for the inverse of that graph at 0, 1. Okay, we had that. We know that you had an asymptote of y equals 0. Okay, so I'm doing all of this I should actually be drawing this in red since I did the exponential graph. So I'm going to do it in red. So the red is going to be representing our inverse, and the blue is the log graph. Okay, so our inverse is where x and y are swapped. So we've got 1, 0, so we end up having 0, 1, right? Then, let's just close that, sorry for my OCD. And then we've got our y equals 0 asymptote. And then we can simply just draw that like that. Okay. So this would be f to the negative 1 of x. Okay. Oh, they want one other point? Okay, one other point. Well, here we go. Here's just a demonstration of what I mean with inverses. This point here was 3 and negative 1, wasn't it? Keep using the wrong thing. I want to be using the document. There we go. Okay, so remember t we got to be negative 1, right? So actually we know we have another point on the graph, negative 1 and t, right? So where x is negative 1, then y would be t. So where is the point negative 1 and 3? This is going to be, this is actually going to be the other way around, because yes, okay, because this is 1 over 3, remember that's 3 to the minus 1. And 3 to the minus 1, our exponential graph would go the other way. So we don't have to change the asymptote or anything, but it goes this way around. Who had a heart attack? or who was screaming at their screens, "You've done it wrong. He's done it wrong." Okay, so it goes this way. A good job we had to draw that 1 point, or we might not have picked this up. Okay, so we know we're going to have a point at -1 and 3 there, right? So that would be the other point we could use, -1 and 3, showing our fantastic knowledge of exponents. Okay, so the question 4.6 says, the graph of h is obtained when f to the -1 is translated 5 units to the right. Determine the value of h where x is greater than 4. Okay, so where is it greater than 4? Okay, so what we want to do is we want to shift it to the right, don't we? So when you translate something 5 units to the right, that changes the x value, doesn't it? So let's just draw this. Let's just write it down, our f to the -1, which was y equals a third to the x. Y equals a third to the x. Now, if you shift something right, that goes that way. If it's to do with the x, that's counterintuitive, meaning you must take it to the -5. Okay, so determine the values of h where x is greater than 4. Okay, so, well, we can break this up. And so 5 units to the right. So let's just draw that. So that would be, I'm going to just draw that. So if we were to move all this to the right, it would go this way, right? Okay. And it would have a new intercept. And so if we were to, let's just draw it here. Essentially what we're wanting is, where is x greater than 4? Right, did they ask that? Or is it h of x greater than 4? Where is x greater than 4? And they want the y values. Okay. Well, if we were to, let's sort of pull x to the 4. We can actually sub in a value of 4 here, and we would get 4 here. And we would then say, well, what are the y values? Right, so what are the y values? So if this is 4, what are the y values over here? Okay, so it's going to be kind of all these ones down here. So all we have to do is figure out what y is where x is greater than, what the y value is when x is equal to 4, and then it'll be all those values, but it'll be between that, and obviously you've got this asymptote. So y will be between whatever this value is here. So we're going to find out what the y value is where x is 4, so here, and whatever the y value is. And it'll be all of these values of y downwards, because this pink, do you see, goes all the way down. But it won't go past 0. So we know, so I'm just going to make a note there. We know, first of all, that y is greater than 0. Now we're going to just find out what y is less than. Okay, so we're going to sub in 4 into this graph. So we'll say y equals a third to the 4 minus 4. So y is equal to a third to the -1, which is 3. Okay, so then we know y is between 3 and 0. So now we can just say, I'll put this in black just so that it's clear. So y is greater than 0 and less than 3. Okay, so that's it. Let me just go back to the top and just demonstrate that one more time. Okay, so we saw that that makes perfect sense. When we put in the 4 here, we should get a value. We know that y here is 3. Okay, and so it's y is between 3 and this 0, and that's where we get all the x's. Okay, so hope that helped, and I will see you in the next one for question 4. If you enjoyed that, or if it helped you, or for whatever reason, maybe you're feeling generous, it costs you nothing but your time, which I know is valuable, please go ahead and gently hit that subscribe button.